First of all, Jai Hind everyone. Myself, Dr. Kanika, Assistant Professor in Department of Applied Sciences and Humanities, Ajay Kumargar Engineering College. So, today I am discussing the topic of Engineering Mathematics first. Subject code is BS103 and my topic is multiple integrals. So, in multiple integrals, firstly I will discuss the double integrals. So, the definite integrals of fx with the range a to b is defined as the limits of the sum fx1 delta x1 plus fx2 delta x2 plus fx3 delta x3 and plus up to plus fxn delta xn, where n tends to infinite and each of the length delta x1, delta x2, delta x3 up to delta xn tends to 0. So, here delta x1, delta x2, delta x3 up to delta xn are n sub intervals of the range b to a, and has been divided, and x1, x2 up to xn are the values of x within these sub intervals delta x1 and x2 for delta x2 and x3 for delta x3 and xn for delta xn. So, a double integral is its counterpart of two dimensions. Now, let a single valued and bounded function f of x y of two independent variables x and y and are defined in a region of xy plane. Now, we have the region R, and firstly we will divide this region into the sub-regions by drawing lines parallel to y-axis and parallel to x-axis. And now, number of rectangles which lie entirely inside the region R, such as this rectangle, this rectangles. Now, from 1 to n, let x r comma y r be any point inside the rth rectangle whose area is delta ar. Now, consider the sum f x1 y1 delta a plus delta a1 plus f x2 y2 delta a2 plus up to f of x and y and delta an is equals to summation of summation r is equals to 1 to n f of x r y r into delta ar. Now, in other words, we can write this summation is equals to the double integration of fx y over a and bounded the region R. Now, which can be also expressed as delta A is equals to dx dy or dy dx. Now, double integral, the integrals double integral of fxy over the region R is called the double integral of fxy over the region R. So, this we can pronunciate this integration as double integral of fxy over the region R or bounded the region R. Now, evaluation of double integral. The method of evaluating the double integral depend upon the nature of the curves bounded by the region R, such as firstly, if the region is defined such as x is bounded by a to b. So, x is equals to a, this line, x is equals to b, this line. So, region is bounded by this line to this line. Now, for y is bounded by curve f1x to f2x. So, we assume that this curve is f1x and this one is f2x. So, y is bounded by this curve to this curve. So, this is the required region. Now, we have to find the double integration of fxy over the region R. So, here over the region R, x is bounded by A to B. Firstly, to find this integration, we will assume a strip, a vertical strip or a horizontal strip. If we consider a vertical strip, then the limit of x will be constant and limit of y will be variable form. And if we consider the horizontal strip, then limit of y will be constant and limit of x will be variable form. And if region is rectangular form or square form, then the limit of x and limit of y, both of the limits are constant. So, firstly we will consider this vertical strip PQ. Now, we will rotate this vertical strip from this line to this line. So, here x is equals to A and x is equals to B. So, we can rotate this strip from x is equals to A to x is equals to B. So, limit of x is A to B. Now, we will we can see this point P is on the curve f1x and this point Q is on the curve f2x. So, limit of y or limit of strip on limit of strip is f1x to f2x. So, limit of y is f1x to f2x. Now, here we can see that the limit of y is in variable form. So, firstly we will integrate fxy with respect to y and then put the limits, and we can see that the function, the concluding function will be in x form. So, then we will integrate the function over x. Now, for example, we have to integrate this function x upon x square plus y square with respect to x and y. So, here we can see that the limit of x is from 0 to a and limit of y is x upon a to x. So, we can see that here the limit of y is in variable form. So, firstly we will integrate the given function with respect to y. So, with respect to, if we integrate the function with respect to y, then treat x as a constant. So, here x as a constant. So, integration of 1 upon x square plus y square is equals to 1 upon x tan inverse y upon x by using this formula. Integration of 1 upon a square plus x square is equals to 1 upon a tan inverse x upon a. Now, we will put the limit. Firstly, we will put upper limit x. So, put the value of y is equals to x here. So, we will get tan inverse 1 and minus sign. Now, put the lower limit y is equals to x upon a, then it will be minus 1 upon x tan inverse 1 upon a, and we know that tan inverse 1 is equals to pi by 4. So, this is equals to pi by 4 minus tan inverse 1 upon a, and now we will put the limit. Now, we will find this function, the integration of this function with respect to x. So, integration of pi by 4 with respect to x is equals to pi by 4 into x, and integration of tan inverse 1 upon a, this is constant term. So, integration of this term will be equals to minus x tan inverse 1 upon a and limit 0 to a. Now, again we will put the limits of x. Firstly, we will put upper limit and then minus sign, then put the lower limit. So, upper limit a. So, put here x is equals to a, then we will find pi by 4 into a minus a tan inverse 1 upon a, and now minus sign, we will put the lower limit, put x is equals to 0, then this term will be 0, and put x is equals to 0, then it will be 0. So this is the answer. Now if the reason is defined such as limit of y is constant from a to b. So this line is y is equals to a and this line is y is equals to b. So reason is bounded along y axis or from here to here. Now the limit of x is f1 y to f2 y. So here limit of x is in variable form. We consider this curve is f1y and this curve is f2y. So this is the bounded region. So we have to integrate fxy over the region R. So firstly we will consider vertical strip. So we will move this strip such like that. So strip can move from y is equals to a to y is equals to b, and first point, begin point of strip is p, which is in the curve f1y, and end point of the strip q, which is in the on the curve f2y. So limit of x is f1y to f2y. Now here we will integrate the function fxy with respect to x and then integrate the output of this term with respect to y, because here the limit of x is in the variable form. Now for example, here this limit is for y, limit of y is from 0 to a and limit of x is from 0 to under root of a square minus y square. So now here limit of x is in variable form. So firstly we will integrate the given function with respect to x, and so due to find the integration of this function with respect to x, we will consider y as a constant term. So integration of a square minus y square and minus x square is equals to this. By using the formula integration of a square minus x square is equals to x under root of a square minus x square upon 2 and plus a square upon 2 sine inverse x upon a. Now we will put the upper limit and minus sign lower limit. So upper limit is under root of a square minus y square, then we will put here x is equals to under root of a square minus y square, and here x is equals to under root of a square minus y square. Then we will find this term a square minus y square upon 2 sine inverse 1. And if we put here the lower limit x is equals to 0, then this term will be 0, and put here x is equals to 0, sine inverse 0 is equals to 0. So this term will be 0. Now the output term is this. Now we know that sine inverse 1 is equals to pi by 2, and so and here 2 already, so pi by 4, and integration of a square minus y square over y with the limit 0 to a. So now we will integrate this function with respect to y. A is integration of a square is a square y, and integration of y square is y cube by 3, and limit 0 to a. Now we will put the upper limit, then minus sign lower limit. So put y is equals to a. So here will be a cube, and minus put y is equals to a, then here will be a cube by 3. Now minus sign, put y is equals to 0, then this term will be 0, and y is equals to 0. So this whole term will be 0. So now we can, now we will simplify this, then it will be equals to pi a cube upon 6. So integration of the given function with respect to x and with respect to y is equals to pi a cube upon 6. Now if the region is bounded such as x is from a to b and y is from c to d. So here the limit of x is constant and limit of y is constant, so region will be in rectangular form. So now here this line is x equals to a, this line is x equals to b, this line is y is equals to d, and this line is y is equals to c. So this is the required region. So now we have to find the double integration of fxy. So here we can integrate the function with respect to x firstly or with respect to y, because here both of x and y have constant limits. So we can find the integration with respect to x or with respect to y, whatever we want. So now for example, here the limit of x is from 0, 1 to 2. So this limit is y, because here the firstly we have to integrate the function with respect to y. So here given firstly dy, so this limit is for y, and then dx, so this limit is for x. So limit of x is from 1 to 2 and limit of y is from 3 to 4. So now we will integrate this function xy plus e power y with respect to y, and now treat x as a constant term. So integration of xy is equals to xy square upon 2 and plus integration of ey is equals to ey, and limit 3 to 4. Now put y is equals to 4 here, so it will be 8x plus e power 4 and minus sign. Y is equals to 3, then it will be 9x by 2 minus e power 3 and dx. Now we will integrate this function with respect to x. So integration of 7 by 2x is equals to 7x square by 4, and integration of e power 4 minus e power 3 is equals to e power 4 minus e power 3 into x, because this is the constant term and this is also the constant term. Now we will put the limits. Firstly put upper limit x is equals to 2 here and here, so it will be equals to 7 plus 2 e power 4 minus e power 3. Now put x is equals to 1, so minus sign, put x is equals to 1, so 7 by 4 and minus e power 4 minus e power 3. So this is the answer. Now next we have to evaluate the integration of y over the region R, and here the region R is bounded by the parabolas y square is equals to 4x and parabola x square is equals to 4y. So firstly we will draw the region. So we draw x-axis, y-axis, and the curve y square is equals to 4x and the curve x square is equals to 4y. So this region, this bounded region by the both parabolas, this is the region R. So now for this region we have to find the limits of x and limits of y to find the integration of y over the region R. So firstly we will take or we will consider a vertical strip, and now we will move this strip from this point to this point. So here x is equals to 0 and here x is equals to 4. So limit of x is 0 to 4. Now for the limits of y we will see this point, begin point of vertical strip. This is on the curve x square is equals to 4y. Now we will find the value of y at this point. Y is equals to x square upon 4. Now the upper limit of y is at this point, and this point is on the curve y square is equals to 4x. So here y is equals to 2 under root x. So limit of y is from x square by 4 to 2 under root x. So now we can find the integration. We calculate the limits of x and limits of y. So put the limits of x and y here. Limit of x 0 to 4, limit of y x square by 4 to 2 under root x, and y dy dx. Now because limit of y is in variable 4, so we will integrate the function with respect to y firstly. So integration of y is equals to y square by 2. So 1 by 2 is constant term, so we can take before the bracket. Now we will put the limit of y here, the upper limit and minus sign, the lower limit. Upper limit is 2 under root x, so put y is equals to 2 under root x, so here will be 4x, and minus sign, put the lower limit x square by 4 here, so it will be x power 4 by 16. Now we will integrate this with respect to x. So integration of 4x is equals to 2x square, and integration of x power 4 upon 16 is x power 5 upon 80, and limit 0 to 4. Now we will put the limits. Firstly upper limit, then it will be equals to 32, and now put 32 minus 1 0 to 4 upon 80. Now we will put the lower limit is 0, then put x is equals to 0, x is equals to 0, then the output is 0, so is equals to 48 upon 5. So integration of y over the bounded region R is equals to 48 upon 5. Now we have to evaluate this integration over the positive quadrant of the circle. Now positive quadrant means first quadrant. Here x is positive, y is positive, so this is the positive quadrant. And now this circle is like as, this is the equation of circle with center 0 and radius 1. So we have to evaluate this integration over this region, because this region is in positive quadrant, first quadrant. So we will consider the vertical strip and move the strip, and for the limit of y we will find the begin point and end point of the strip. So here this is the curve, this is this part of the circle, so this is the curve. Now we will take this strip, this vertical strip, so this vertical strip can move from here to here. So here x is equals to 0, and here x is equals to 1, because the radius of the circle is equals to 1. So limit of x is equals to 0 to 1. Now we have to find the limit of y. So we will take this point. This point is begin point of the strip, and this point is the end point of the strip. So begin point of the strip is on this line, y is equals to 0. So lower limit of y is equals to 0, and end point of the strip is on this circle, on the boundary of this circle. So this circle x square plus y square is equals to 1. So we can find the value of y here. So y is equals to 1 root of 1 minus x square. So upper limit of y is under root of 1 minus x square. So put the limits of x and limits of y and integrate the given function with respect to x and with respect to y. So because limit of y is in variable form, so firstly we will integrate the given function with respect to y. So with respect to y, x treating as a constant, so it will be here, and now integration of y and root y upon root of 1 minus y square is equals to minus and root of 1 minus y square, and limit 0 to under root of 1 minus x square. So to find the integration of y upon 1 minus y square dy. How to find this integration? Here we put directly the value of integration. So now we will I explain this integration here. So let y 1 minus y square is equals to t. This implies that differentiate on both sides, minus 2y dy is equals to dt. This implies that dy y dy is equals to minus 1 by 2 dt. So integration of this integration will convert as this form, y dy is equals to minus 1 by 2 dt, and upon 1 minus y square is equals to t, so t power 1 by 2, and limits, and we will put limits after find this integration. So is equals to, and minus 1 by 2 integration of t power 1 by 2 is equals to uh, integration of t power minus 1 by 2 is equals to t power 1 by 2 upon 1 by 2. So this will be equals to 2 t power 1 by 2, and 2 is cancelled to this. Now we will put the value of t here. Value of t is equals to 1 minus y square, so here will be in root of 1 minus y square. So integration of this is equals to minus sign here, and t power 1 by 2 is equals to 1 and root of 1 minus y square. So integration of this function is equals to minus and root of 1 minus y square. Now we will put the upper limits and root of 1 minus x square and minus sign the lower limits. So this will be equals to this. Now we will firstly we will simplify this, and here 1 is cancelled out, and minus and root of 1 is equals to 1. So we will so under root of, so x minus 1 here, yes, x into x minus 1. Now multiply this x in the bracket, so x square minus x. So integrate x square minus x with respect to x. So integration of x square is equals to x cube by 3. Integration of x is equals to x square by 2. So put x is equals to 1 here. So 1 by 3 and minus 1 by 2, and minus sign, put the lower limit, x is equals to 0 and x is equals to 0. So terms will be 0. So is equals to 1 upon 6. Now next question, let D be the region in the first quadrant bounded by the curves x y is equals to 16. X is equals to y, this is line, y is equals to 0, this is x axis, x is equals to 8, this is the line parallel to y axis. So now sketch the region of integration of the following integral. So we have to evaluate this integration over the bounded region D. So firstly we will draw the bounded region. So for the sample, for the trial, I will draw this here, x-axis, y-axis. Now draw x y is equals to 16, x y is equals to 16 is the curve like this. So x is equals to, this is the line, x is equals to y, this is the line, x is equals to y, and now y is equals to 0 is the x-axis, and x is equals to 8, this is the line, x is equals to 8. So this is the bounded region. So firstly, sorry, yes, this is the x y is equals to 16 curve, this is the y is equals to x line, this line is the x is equals to 8. So now we will consider two strip, because if we consider one strip then it will be it can rotate. If we consider here a vertical strip, then it can rotate from here to here, the point, shaft point. So a strip can't rotate after this point. So we have to consider two strip from to move here to here and to move here to here. So firstly we will move this strip from here to here and find the limit of x. So limit, to find the value of x here, we will find the intersection points of x y is equals to 16 and y is equals to x. So intersection point will be 4, 4, and intersection point here, so it will be 8, 2. So limit of x for this strip, limit of x is from 0 to 4 and limit of y is from 0 to this line. This line is y is equals to x, so limit of y is 0 to x. And for this strip, limit of x is from 4 to 8 and limit of y is from y is equals to 0 to this, here y is equals to x upon 16, so limit of y is 0 to x upon 16. So here we have two regions, OAMO and AMNBA. So and we will find the integration for both the regions and add the integration to find the whole region. So integration for the first region and second region, and similarly we have already find these types of integrations already. And now here this is the questions, this is the question, and similarly we can find the integration of y over this region. We will consider the vertical strip and rotate this is from here to here and find the intersection points, and then we can find the limit of y and limit of x. And now these are the references books. Thank you.